On last we left our engineer, he did his best attempt at making rotation interesting. Perhaps he won't fail in this week's installment of Vay's Projects, the ButterBot.
So the B frame is rotated theta 2 from the A frame, and the A frame was rotated theta 1 from the N frame. This rotation is marked in the x direction by cosine theta 1 minus sine theta 1, and then for the y, sine theta 1 plus cosine theta 1 times their relative vectors. That's what this symbol means. It means a vector. Now I just said a bunch of stuff that you might not understand, so I'm going to go back through it in a way that'll make more sense. This stick is offset from this stick by this. And this stick is offset by that stick by this. But we want to know how much is offset by, because this means nothing and can be anything. Ooh. And so we got to use these symbols, which have tables and meanings in a calculator, to find that. Yeah. And then from here, we can actually do the position analysis. So now that we have the rotation marked off, that's a helpful tool that'll help us later when things get more complicated. Now we can start marking positions. And just a real quick, this is called, there are two kinds of ways you can do dynamics. The primary way that I know is called vector dynamics, which was invented by a professor of the school that I go to. That's this way. So if you don't recognize this way, then you know what you're talking about, like way more than I do. The reason my way might look different than the way you know is because it's kind of unique to where I go to school. But I like this method. I learned both, and I prefer this one a little bit. So we'll move forward. Now we gotta do with the position vectors. And another explanation on vector. You've all seen Despicable Me. A vector has direction and magnitude. All right, position vectors, we mark them with the letter P. Try and guess why. We need to go from here to here through that. So we're gonna have an arrow going this way, an arrow going that way. So we need to go P, N to A. Point N to point A. This is L1, and it follows the A frame. So it's going to be equal to L1 X A. Now we need to go A to B. That's going to be equal to PA B L2 X hat B. And then finally, we need to go back from B to N. Now some of you might think you can just go back to the link, but if we do that, we'll just get 0. You go all the way forward in a specific direction, go all the way back in the same direction, you did nothing. Your net is 0. You wasted your time. We don't waste time here. So we gotta go this way. Because that makes sense. I'm gonna label this E because I don't follow the rules. And label that F for the similar reason. So we need to go down E and across F. So P, B to N is going to be equal this way times that way. But what frame does that follow? I think you know. The N frame. It's coming back, isn't it? It goes down the Y frame here. So minus E, Y, N, and then plus F, X, N. And if this is the first time you've seen a negative number since high school, I'm sorry. Now that we have all the position vectors, we can start doing some serious analysis. There is an issue though. We have variables. 4 variables to be exact, because these are problems. Yes, theta 1 can move because it does that. And yes, theta 2 can move because it does that. But when this whole thing moves together, this changes and this changes. Now, I know through some meta-knowledge that we're really only supposed to have 2 equations by the end of this, which means we can only really have 2 variables. And right now we have 4, which means we need to do something else. And through the power of meta-knowledge, now you know that. So good job. So we need to get rid of this. And we need to come up with an equation for this and this using these terms. Let's do it.
Will we do it? Is this going anywhere? Did anyone notice that this video didn't take a week to release? Find out next week on Vay's Projects, the ButterBot.